Hello and welcome back. Today we have 242 valid anagram. It says here we're given two strings s and t, and we are to return true if t is an anagram of s and false otherwise. And an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. And what this translates to is basically for any word. So let's say we have, robot, and we have robots. So yes, we can create this word from this word. However, this is not considered a valid anagram because by the time we use this to create this, we still have s remaining. However, we can rearrange this. So let's say there's some word that is TOBRO, which is this first word rearranged. Yes, this can be used. If we have a Scrabble board with these characters, we can reassemble it to create this word. And the easiest way we can do that is by comparing the counts. So for instance, for this first one, we have one R, we have one O, we have one B, we have another O, and one T, just like that. For this guy, we have one T, one, oh, actually, you know what? Let's do it this way. Can we compare? Yes. We have one T, great. We use up the T, and T is now 0, so let's kill it. Okay, T is done. O, yes, this has an O, so let's use 1, great. We have a B, we use up the B, now this is empty, so let's remove it once again. We have an R, yes, we have the 1, use it, and then remove it. And then the last O, we have it, and then we remove it, and then we can say, are the counts now empty? And if so, we've just reassembled the word successively using all the characters in the other word. But let's say we were actually trying to assemble robots, then S would be missing here, so we would return false. Or rather, what if we were trying to assemble robot from robots? Then this would be the reverse, where it has an S with a count of 1, and at the end we would check, okay, this is empty, right? Nope, it's not empty. It actually has 1 S remaining, and so once again, this would be a false anagram. Okay, so now if we translate this to code, pretty simple. We first get the counts of the first string, just like we did in the drawing. We can do this a number of ways, but we'll do it the manual way for this approach. So let's say we have some counts, okay, and we're saying for every char in S, we're going to say counts of that char is going to be 1 plus whatever it was before. Now that may be already existing, but if not, we'll just initialize it to 0. Okay, and at the end of this, we get the char count mapping of the first string, which is anagram in our first example here. Great, we processed our first string. Now we compare with our second string. So just like we did in our drawing back here, we're going to now compare our existing counts of the first string by going through every character in our other string. Okay, so let's say for char in T, which is our second input string, let's say, first of all, if the char is not in counts, then that means whatever char we're trying to assemble is not even in this other word. Then, okay, return false. We don't match. Great. The other thing is, then that means that this char does exist. So let's say counts of that char, we're going to decrement it. But then if the count ever reaches 0, so if the count ever reaches 0, we want to remove it from our mapping. Okay, so after decrementing, if the counts of that char is ever equal to 0, then okay, we've used it up, let's just delete it. I think that's how you do it. Okay, and at the end, we can say, all right, we've done the processing, we got the initial counts, then we compared the second word char by char with the first word's counts, and at the end, if these are valid anagrams, then that means this should be empty. So say we return not counts. Okay, and that should work. Okay, I think that's gonna work. And there you have it. Here we go. And so this, once again, was 242 valid anagram, where we use time of O of n. We loop once through the first word. We loop another time for the second word. That is 2n reduces down to O of n. And then for space, we do use O of 1 because we store the counts mapping in a separate hash map. And yeah, that's it. If you are interested, there is that famous way to do it, which is just using counters. So that would be return, counter of s, which basically does this for us, and we're going to compare that with the counter of t. And that is indeed another way. And that also works. All right, and yeah, quite efficient. All right, thanks so much. Happy coding. See you next time.